Welcome everyone. Today we will get started with our learning journey on Java. We had looked into some general concepts with respect to development, including algorithms, pseudocode, and even algorithm analysis, such as asymptotic analysis. Irrespective of what programming language you work with, most of those topics are relevant. We will not discuss much about those from now on, but every time we do some kind of program, you have to actually put those concepts in practice by analyzing what is the time complexity of that program, and then you have to share with me. Coming to Java, I have been teaching Java for maybe more than 10 years. And based on all those teachings, I have prepared my own notes. I'm updating them as and when we are having our classes for a particular topic or a module. I'll be directly going through my notes, and then I'll be explaining things. And make sure you ask any doubts you have on the way. And there is also one more advantage for this approach, because these notes are available to you. So you can easily go through them whenever you have time. Because whenever you are preparing for an interview, or whenever you are preparing for real work, or even whenever you are referencing things, going through all videos will be difficult. So going through notes will be easier. And if the notes and the classes are completely in sync, then it will be much easier for you to actually figure out where the content is, and then directly go to that content. And that said, you also have the advantage of asking me any questions that you have while we go through these notes together, and then learn and grow together. And that said, we'll be doing some hands-on exercises in between. And for that, you will need a computer, and also you will need internet to download the required tools. So are we ready to get started? So this is my blog where I generally update my notes. Do not worry about the dates. The dates might look older. That was the time when I first updated these notes, but I have been updating it regularly after that. We have different modules. So first of all, we will see all the essential with respect to Java. Then we have core concepts such as classes, objects, variables, methods. Then we have operators, decisions, and even looping and checks. We will see object-oriented programming, which is a very important part of core Java. And then we will see arrays and array lists, exception handling, inner classes, and more, lambdas and streams. And each of these modules will have a set of nodes which we will follow, and it also has a set of exercises, and also it has different sets of multiple choice questions that you can practice. What you have to do is whenever we complete a module, so some of these we might do in the class itself. If you have not done it, then you will be doing it on your own. Quick introduction to Java programming. So Java is a high-level programming language that follows the object-oriented principles. Object-oriented principles are principles or concepts that revolve around the concept of objects. So what are these objects? So whatever you see around your pen or pencil or glasses, computer, everything that you see around are kind of objects. And what are the common things that objects have? So they have some kind of behavior. So if it is a car, then it has some kind of behavior. If it is a laptop, it has some kind of behavior. And if it is a TV, it has some kind of behavior. So every object will have some kind of behavior. And also these objects will have some properties. For example, they will have a weight or height or a width. So they will have different kinds of properties. So consider human beings. Human beings have height, weight, various characteristics, right? All these are the characteristics of objects. So every object will have behavior and characteristics or properties. So these properties are specified through the use of fields, as we will see later, and then behavior is specified through the use of methods. Java is syntactically and structurally modeled after C or C++. So when C came, it followed something called as a procedural model. So C++ embraced object-oriented principles, but again, in few areas, there were flaws in the C++ approach, and you could lead to accidental mistakes or some kind of mistakes that cannot be avoided. So there were guidelines to avoid them. So Java went one step ahead and made sure that those features are removed from Java to have to provide you with a much safer environment to work. Okay, one of the important differences that Java has from other languages is that Java has always tried to avoid accidental mistakes. Java removed some features from C or C++ that were prone to errors, like pointers, destructors, etc. Java also added features such as automatic memory management called garbage collection. Java do not support multiple inheritance to avoid diamond problem. If you have time, then we will discuss all these problems later. Java is interpreted at runtime rather than compiled like C or C++. We will see that also in detail in some time. But Java also performs compilation and does various compile time activities. Unlike other interpreted languages, Java is platform independent. Java executable uses an architecture neutral bytecode. The bytecode is something that is an intermediate optimized form of source code. So it is not purely source code, and it is not an executable code. So it is somewhere in between. But so compared to directly converting and executing a source code, it is much efficient and faster. So the bytecode are interpreted and executed by a platform specific Java virtual machine installed on that platform. Okay, so unless we are practicing, so I'll be taking things much slower and then closer to the notes so that you can even hear this while you are doing some other activities. So, but labs and other things, you definitely have to look into the screen. So Java also supports many other features such as threading, networking, security, graphical user interfaces, etc., that we will see in our advanced classes. Again, introduction to programming. The purpose of programming is to develop an executable computer program that will automate performing a specific task or solving a problem. Many people ask me questions about whether I can learn programming, and there is already a question what we need to be a best coder. So the answer is, and I will ask another question, what is needed to be a best swimmer or best cycler or best racer? It is practice. In the same way, if you practice regularly, you can be also a good coder or a best coder. There is nothing stopping you from doing it as long as you dedicate some time to practice. Anybody can do it. It is not limited to some people. Just like swimming or any other activity, if you try to learn from YouTube videos or any such courses and do not practice, imagine going to swimming, most likely going to drown. So please practice regularly, and that is only way to become a good coder. You have to do many things. You cannot directly jump into writing a program or creating an application. It involves many stages. So algorithms we already saw, and algorithms, and then how you can analyze algorithms in an earlier session. So we are slowly moving into the actual thing that is Java. And this different phases of developing a software is generally referred to as a software development life cycle. Programming languages are used to write programs. Programming languages like C, C++, Java, Fortran, JavaScript, yes, Python, Ruby, Smalltalk, etc. There are a lot of languages. So they are similar to our communication languages. And while we can use communication languages to talk to different people, you use programming languages to tell computers what to do. Computer platform might understand certain language and is usually called a low-level programming language. A low-level programming language is a programming language that provides a little or no abstraction from a computer's instruction set architecture, commands or functions. So do not worry about all these terms. In simple terms, your computer will understand certain things. Those things are abstracted away from you by your operating system. And again, operating system will understand certain other things. So those things are abstracted away from you by these high-level programming languages. So this high-level programming language has to be converted to a platform-specific. When I say platform, it is your operating system, and this operating system may have different processors behind the scenes, 64-bit or 32-bit. All these combinations may have different executables. So you need to have somebody to convert whatever you say to those people. So two such software are compilers and interpreters. So compilers will first compile, and then it will execute that executable any number of times. Interpreters directly convert them on the go, and then they will execute it. Consider that I am the king of a state or king of a small country. Then I want to imagine that this is a new country in South India, so that speaks some language called Cloudrix. This country or this state wants to communicate something with the people of nearby states like Kerala or Karnataka or Tamil Nadu or Andhra Pradesh. So what options I have? I have so imagine that I know only Cloudrix. So what will I do? I have two options. Either I can call somebody. I can call one person who knows Cloudrix and Malayalam. Then I will send him to Kerala. So after going to Kerala, he can talk that thing again and again to all those people in Malayalam. And if another person, I'll send to Karnataka. So that person can speak again and again in Kannada. And another person I can send to Andhra. Another person I can send to Tamil Nadu. So all those people will be able to speak in their native language faster. That is one way. And another approach is I am sending one person, or I am itself going to that place, and there will be somebody who knows Cloudrix and Malayalam or Cloudrix and Kannada, and they'll be translating on the go. So this translation process is similar to interpretation or interpreter, and so sending somebody who already knows things can be considered as a compiler. Tell me in the chat. So which of these will be faster? Okay, it is a compiler, right? Compiler is faster. So whenever I am asking a question, if you are tired of typing everything, you can just type the first letter. So if I am asking compiler or interpreter, you can even say C or I. You don't have to type completely, but you have to type, because otherwise, in the end, if you say that, okay, you promised us that, okay, in 4 months, you will be a complete cloud expert with programming language knowledge, data structure knowledge, and live project, and all these things. Then I will also take up these chats and then show you how much you actually participated. Without participation, I cannot make you an expert. Nobody can make you an expert. So you have to participate and you have to practice. So do I need to have any particular software installed in case of in the client machines, wherever the code is executed? Do I need to have any specific kind of software that needs to be installed? I don't need any software that needs to be installed, because I have already converted it into a platform specific form. You will be downloading a lot of .exe software in your Windows machine, right? So do you need any other software to execute it? No. You can just double click it and execute it, because that is already in a form that can be understood by your Windows operating system. So compiled languages in general, most of them do not need a separate software to get executed if they are already converted into that particular platform. So now tell me, for interpreted languages, do I need any extra software that needs to be installed on the client machine? Even in the case of a physical example, you have somebody there, right? That person is called as interpreter. And in case of interpreted languages also, that software is called as interpreter. There is a question, compiler and interpreter transform languages to 0 and 1. Computer only understands 0 or 1. So you are, in most cases, you are not directly executing commands against your computer's processor. You are executing against your operating system. So your operating system has already abstracted away that zeros and ones from you. Whatever you are executing, if your operating system can understand it and convert it into zeros and ones and tell your processor, that is good enough. Okay, so there are different layers of abstraction, right? Whenever you are going to download a software that is created using a compiled language, you will see a download for Windows, download for Linux, a download for Mac. Some languages, maybe even a combination of compiled and interpreted languages, such as Java and Python. High-level languages versus machine language, we already discussed. Somebody has to do that conversion. And compiled and interpreted languages, we already saw that, okay, compiled languages are faster than interpreted languages. So can you tell me some advantage of interpreted languages? I ask it another way. So tell me, which out of these compiled or interpreted languages will be more error-free during runtime? Okay, I actually tricked you into telling interpreter because I asked about interpreter and then I asked this question. So everybody would ideally think it is interpreter, but the answer is compiled language. For compiled language, you are already doing that conversion to a platform-specific form before even giving to a client. Before even giving to client, you have already converted it. So while that conversion, you can figure out if there are any errors. For example, if you have created a number variable, and if you are trying to assign a alphabet, so it could fail. So during compilation phase itself, you can find out, okay, there is something wrong, and then you can prevent that from going into runtime. But with interpreted languages, you like convert and execute line 1, convert and execute line 2, convert and execute line 3. So if when you reach line 7, if you are finding some issue, you are stuck with that issue. Better error handling or less errors are possible at runtime with compiled languages. So that is the second advantage of compiled languages. And the advantage of interpreted languages, I think only one person here had mentioned. It was Alan who mentioned that it is platform independent. Interpreted languages are platform independent, and basically they are called as write once, use everywhere. The same application I can ship to all different platforms, and those platforms will have a software called as interpreter who will be converting this into that particular platform's understandable form. Clear? Pros for compiled languages. Since the source code is already converted into a native platform-specific code, the code can be executed directly without any more translation. Type checking. Since the compilation work in phases and has access to whole code and types declared, it can do syntax checks and type checking, and this avoids any possible runtime errors due to type mismatch. If you have a variable of type int, and if you assign it any other type, and then if you use an int operation, your code might throw a runtime exception. These kinds of issues can be avoided with the extra check that compilers do. And the advantage of interpreted languages is definitely portability. Since the source code itself or a platform independent executable is shipped to the target machine, the executable is platform independent, and hence it is portable across platforms. However, note that there should be a platform specific interpreter installed in the target machine that can convert this platform independent executable to that particular platform specific machine code and execute it. There are languages such as Java and Python, which has both compilation and also interpretation. In Java, the source code is compiled into an intermediate platform independent bytecode, and this bytecode is then interpreted. Python is another compiled and interpreted language. It also uses the combination of compiler and interpreter, and the compiled output is an intermediate code, which is then executed by the bytecode interpreter. In Java, we already learned, right? So Java is a interpreted and compiled language. So first, your source code will be compiled, and then it will be interpreted. So first, when the source code is compiled, it will provide, the output will be an intermediate form, which is called as bytecode. And then this bytecode will be interpreted by an interpreter, and this interpreter is called as JVM. So you have your source code, which is .java files, which is then converted into your bytecode, which is .class files. And finally, this .class files are executed using interpreter. And this interpreter is generally referred to as a Java file itself. So if you are in a Windows machine, it will be java.exe. And the compiler is generally called as Java C. If you are in a Windows machine, it will be java c.exe. Okay, so this compiler will be a part of a package called as Jdk or Java Development Kit. And this interpreter will be a part of a package called as Java Virtual Machine. And because people who are compiling or people who are implementing will also need to execute, whenever you are installing Java Development Kit, your JVM or Java file will be also part of it. But on the other side, if you install the Java runtime environment, which contains the JVM or Java virtual machine, then you will not get the compiler as part of it. So if you are in a Office machine, in most cases, your machine will have Java installed, but it is just Java and not JDK. It will be JRE in most cases. Okay, so now if you have not installed Java, then you have to install Java now. Java has various versions. So Java's versions, earlier we had 6, 7, 8 and all. So from 8, they changed many things. So now they have this concept of a long-term supported version. So after 8, you have 9, 10, 11, 12, 13, 14. The latest stable version is 11. So we will be using that, or the long-term supported version, especially since we will be moving to cloud. Most of the cloud providers will support only the latest version, which is JDK 11. And the next long-term supported one is 17, I believe, and it will get released soon. But even if it gets released this year, for cloud providers to adopt it, it will take considerable amount of time. So we will stick to Java 11 for our exercises. You can also simply search for Java download, and you might see a java.com link on the top. Do not go there. Go to oracle.com link. And as you can see, latest is Java 16. Scroll down. You'll get Java 11 as the LTS or long-term supported version. So you can download this JDK and you can install it in your operating system. So can you please install and confirm that you have done? So steps will be, you have to go to the Java website, download the one for your operating system, and then install it. It is a very intuitive user wizard. You have to click next and so on. If you have any doubts while installing, you can let me know. There are detailed steps here, but again, I think it is pretty straightforward. So after you install, it will be part of some operating system folder. It will be somewhere in your system. So sometimes, or in most times, it will be automatically added to the path variable. So path variable is a variable that operating system looks for. So whenever you are executing a command, called java.exe or some command, so then first your operating system will check whether the executable file corresponding to that command is present in this folder or current folder or not. If it is not there in the current folder, your operating system will look into the path folder. Okay, if you look into the path folder and see whether that is part of the path folder or not. You can look into the path folder in both Windows systems or Linux systems. In Windows, you can do this set path equal to, you can say path, and then it is separated. Each folder is separated by this semicolon. So here I am saying a percentage path percentage, because this will add whatever was already there in path to this path. Okay, asking for a login before download. Yeah, it is free. So after Oracle took over Java, there has been many changes. You can freely log in and download. In Unix-based systems or Mac, you can you have the path is separated using colon. In Windows, it is a semicolon, and Unix or Mac, it is colon. I am using a Mac, so my terminal will look like this, but in your case, it could be different if it is Windows. And if anybody finds it challenging, I can even share the Windows lab from my different laptop in next class. In Linux or Mac, you can use echo $path to see the contents of existing path. You'll see a folder. So most of the executables will be there in the bin folder. So you have to add that bin here, and next bin, and all those things you can find. So here it is bit older one, Java C minus version, to check the version of Java C. Do not keep it for tomorrow. Install it today itself. Maybe after the class also it is fine. Okay, let me move forward a little bit more. If you are okay, so once you install Java, you will have class files, the ones we said, right? So those class files, if you want to specify where a class file is present, then we specify using minus class path or minus CP. So class path and path are different. Path is something that is used by your operating system. Class path is something that is going to be used by your Java program itself. Okay, and then in Unix or from command prompt, dot means current folder. Okay, dot means current folder, and dot means parent folder. So if you do cd space dot, you'll go to your parent folder, and if you do cd space dot, you will stay in the current folder. So whenever you are executing, you may have to specify these commands too. So now you have a few things, Jdk and Jre. We have discussed it already, where hello.java file, whatever Java code you write, will go to Java C, and it will go to, it will become hello.class, which is the bytecode, and that is executed by your Java file, which is part of Jre, and you get your output. To test, you can use this symbol program, because we can use IDs later, but initially try to practice it from your system itself. From your command prompt, you can type notepad space your file name, maybe hello.java or whatever, and then you can open that file from there, and you can type all these contents there. In alternate classes or in between, we will have meeting modes, and in meeting modes, I'll be looking into your machines. So now in this is a webinar mode, right? In the webinar mode, I'll be showing my system, my things, and in the meeting mode, you will be sharing your system, and you will be showing me how you do things, and if you have any issues, challenges, I'll be helping you out. You have to type these things in a file, and that file has to be saved as hello.java. So by default, if you save it from notepad and all, it might get saved automatically as hello.java.text, because .text is appended by default. So whenever you are saving from notepad, you have to put that double quotes, and then add this code, and then execute Java C hello.java, and you can, so Java C hello.java, when you execute, you will get a file called hello.class, and then you have to only do Java hello. Even though the output of a Java C is hello.class, you have to just say Java hello and it will get executed. And we can quickly read through other information. So we learned, right? So we learned that Java is primarily an interpreted language. People might think, okay, Java is going to be much slower than other languages, but Java's interpreter has a feature called as just-in-time compilation. Basically, if the Java's interpreter sees that, okay, this portion of code is executed many times, so what Java's interpreter will do is that it will compile it during interpretation and then save that compiled code, and then it will be executed. So this is referred to as just-in-time compilation. So for such code, then initial compilation may take time, but after that it will be executed faster. So whenever you are executing one program from your machine, it does not matter a lot. But most of the like applications such as web servers and all will be running for days, right? Days or weeks or months. For such applications, it makes more sense. Java language specification is a document that specify how Java interpreter should be, how Java compiler should be, and all. And anybody can follow those guidelines and then implement their own versions of JVM. So Oracle provides its open source and commercial JVMs. IBM has its own JVM. So Amazon was building something for Amazon Cloud. So you have different versions of JVM, but all of them has to follow the language specification. And Oracle's version has this feature, and is called as, that version of JVM is called as Hotspot Jvm. Okay, hotspots are sections of code that are executed more than once. Your Hotspot Jvm will compile it and then cache it. So all of you are done with your Java installation, and okay, can you share link to Java program download? Just a second, I'll share. Okay, it got installed. Okay, so the link, so you can, so for the sample code, you can check out my blog, which is javajee.com. You can just type this javajee.com. I have not been updating it for quite a long time. And so here, once you come to the front page of this website, you can go in the right side under Hotbooks, you have Java Programmer 1 course. So as I mentioned, other notes may not be updated, but as and when I am taking these classes, I will update it. So you have to just go to your command prompt and type Java. So like I did in my terminal. So in Windows, if you search for CMD, it will open your command prompt. Maybe in tomorrow's session, I will join from a Windows machine so that I can show those things. If anybody, at least one person, has doubts or is not able to execute, I'll join from Windows machine and I'll show tomorrow. So all you have to do is type CMD. So once you type CMD, it will open your command prompt. And once you open your command prompt, it will be more or less similar to my terminal on Mac. And then you can type for Java minus version or Java C minus version. You should get Java 11 there. Yeah, it got installed. Yeah, it is showing version. Perfect. So if you have any doubt, just ask me. That is the best part about live trainings. You can see these videos again later also in YouTube or wherever it is uploaded. In the meeting mode, we will be having more closer discussions where you will be sharing your screen rather than me sharing screen, and I'll be working alongside you, and I will make you program. In Java, you have this concept of like classes. So in C++ also you have this concept of classes. So class is kind of a blueprint for a object. So Java is an object-oriented programming language. So you will be modeling objects. So you need to have a structure for that objects, right? So if you are creating a human beings class, that will have a structure, and that human beings class will be having objects of objects like Hatin or Arjun or Agil or Michael or Prince or Vignesh All these people, Balram, Swapnil, Deba, Prabha, Harsha, Vineet, Susmita, Varun. I'm just trying to mention everybody's name so that Alan, so that you will not feel bad about it that I told somebody else's name but not my name. Okay, so it could be any of those. That class will be common. It will define the common behaviors or common fields. For example, height, weight, all those things will be different for different people, but the common fields, whatever fields are there, will be declared as part of the common blueprint, which in this case is class. And we will be learning all about classes later. So class will encapsulate all those properties and behavior. That is the first thing. And then you create a class using a keyword called as a class. That is the second thing. So you say class and then give a class name hello. And now before this class hello is the important thing, and everything inside that class you will put inside these two curly braces. This is especially for people who said programming is difficult. I am taking it very slow, and I will make sure that you have understood everything, and at the end of this course you will definitely be a good programmer. So I have taught even students from school, and I can take it in any pace as needed. And if you are not able to understand even the slowest pace, then I will personally join in another meeting, and then I will help you out. But it is a guarantee that I will make you a good programmer at the end of this series of classes if you seriously participate. Coming back, you have a class hello, and then you have these curly braces. You have this public static void main. So this is a method. So what did we say about methods? Methods are things that denote a behavior. So you have a class, and inside that class you can have fields or variables, and then you can have methods or behaviors. So in this class there are no fields or variables, and we will be seeing them later. But there are few important things to understand even from this small class. First of all, you define a class as class hello, and then you have curly braces starting and ending. And then you have this public thing. What is this public thing? So whenever you specify a class, you specify an access modifier. Who can access it? So there are different access modifiers that also we will be seeing in detail. But for now, you have 4 access modifiers. One is public. One is default. If you do not provide anything, it is called default. So you can avoid giving anything here. And then you have protected, and then you have private. Okay, the order is private is the most restrictive, which means that you can have access only within a class. So can I make this class as private? Yes or no? So what definition did I say for private? Private means it is accessible only inside a class. So this class, is it inside another class? No. So if you can, Java has this concept of one class inside another class, which is called as inner class. So if this was an inner class, then this can be made as private. But outside classes, you cannot say that this class can be, if I am telling you this class can be only accessed in the contained class, then you will ask me, where is the contained class? So this class is not part of any other class, so it cannot be private. Protected also, it is similar. So we will, it is related to inheritance and all. It is much more serious, so we will completely ignore it for now. Default means it says that it is accessible only within the same package. We have not learned package. So once you learn package, then you will understand default. So public means everybody can access. We have kept public, and it could be even default. And a top level class can be default and public, both will work. But inside this method, public static void main. So this method always has to be the same. So public followed by static, followed by void, followed by main, and then inside brackets you have this thing, strings, square bracket, argus. Okay, this argus name can be anything. It can be argus1, argus2, or heartin, or whatever name you can put for argus. Otherwise, rest of the signature has to be exactly like this. And for people who already know Java, so this method is also just like any other method. The only thing is that your JVM knows that to call such a method with all these things like public, static, void, main, string, argus. So all these things satisfy, then your JVM will call this method. Otherwise, if you forget about JVM, this is just like any other method, and we will be seeing learning about a lot of other things like overloading and all. Everything applies to this one also. So now public means everybody can access. So who will be executing, who will be calling this? Because this is the first method, right? First method has to be called by JVM. Rest of the methods can be called from here. So first method has to be called from JVM, which is outside of this class, outside of this package. So it has to be public. And main is the name of this method. So public and main is clear, right? So this method is not giving back anything to the JVM or the caller. So this method is not giving back anything to the caller. That is specified using void. So just before the method name, you need to specify the return type. So here return type is void, means this method is not going to return back anything. Do not worry, we will have dedicated class for methods where we'll be discussing all these things again and again. And then static means this method belongs to the class. If there is no static here, then this method belongs to the objects. So we mentioned, right, human being is a class, and then the class has objects such as Hartin or Vignesh or others. So this human beings class, he in this case the hello class, can have objects like hello1, h1, whatever names we want to call. So if static was not there, you will need to create an object, and then only you can call this method. But we don't want to trouble JVM so much. So what we can do, we can simply put static here so that JVM can directly call this method without creating an object. Static is used to show that this class can be called without instantiating an object of that particular class. Yes, true. And then the last piece in the puzzle, system.out.println. It is a statement that print hello to the console. Clear? So once you have a file, so once your file has these things, and once you save it, and once you do javac.exe, javac space, so the commands you know, right? First you have to say javac space hello.java. This hello.java is the name of your file. And after that, you can say hello.java space hello, and it will get executed. And finally, you will see the output as hello. There is a question from Vignesh. Do we need to give the exact class name to the file name? Is Java case sensitive? Okay, very good question. We would have discussed it in a different class. There is a rule that says if your class has, so if the class has a public, if the file has a public class, okay, if the file has a public class, so this is a public class, right? Public class hello. Then your file name and this class name has to match. But if this public is not there, then there is no restriction. You can have your class as a class hello world and your file as hello.java. It is perfectly fine. Okay, now answer me one question. How many classes I can define in a single file? If you know, you can answer correctly. If you do not know, you can make guesses. How many classes I can define within a single file? So the answer is any number, but there can be only one public class. The reason is because a file can have only one name, right? And that name has to be same as the public class. So if you have two public classes, then the file will need to have two names. That is not possible. So your file can have only one public class and any number of default classes. Clear? One more question. I have one public class called hello in a file called hello.java, and I have 10 other default classes in the same file. Hello 1, hello 2, hello 3, hello 4, hello 5, hello 6, hello 7, hello 8, hello 9, hello 10. Okay, it is like playing with my kids. Okay, so now tell me, in this particular case, how many dot class files will be created? Let me see who will be the first person to answer. Winner is Swapnil and Alan, who said 11, because I have one public class and 10 default classes. Even though they are all defined in the same .java file, they will all have their own dot class files. So there will be total of 11 dot class files. If you want, you can experiment that also as an assignment and share the results. The more you practice, it will be very, very easy for you to learn Java deeper. And as I always say, there are lots of opportunities for Java. So that is one very specific reason why we choose Java and React for our live project. So we will have other project running in parallel with .NET and React, and maybe in future .NET and Angular. But for now, we choose Java and React because of their job opportunities in market. And as always, today's special code, you can message it directly to me. So the more messages I see from you, maybe I will decide to call you and speak to you one-to-one, and then know about your problems and then help you more personally. Because we have 60,000 plus people in our community, and I will not be able to call all of them. But the more you message me, more you share your problems, more you attend sessions, and more you stay towards the end, you'll be more familiar to me. And then I'll be also in a better situation to help you more closely. Yeah, so yeah, we have a 15-year-old also learning. That is a very good thing. So we had, because in my last batch, we had people from 9th grade who are learning Java. So anybody can learn Java. The only thing is you should have that interest to learn. And if you have that interest to learn, everything else I can definitely help with. Okay, I'm hoping you are all part of either the Java 001 WhatsApp group or Cloud 001 or Cloud 002 WhatsApp groups. If you are not part of it, I'm just mentioning another number where you can WhatsApp, and then I'll add you there, or you can just send a mail to support@buddytutorial.com. Interns there will definitely help you out. So it is a community learning platform, and some trainers like me who want to share knowledge without taking any fee. And there are also some trainers who will be charging a fee. Those fees are actually those charges are actually from fees itself. It's a new concept called community learning. You can read or watch all about it from the YouTube channel or from the respective pages in the website. But for now, we will wind up. Please finish this exercise today itself. If you procrastinate it for tomorrow, that tomorrow is not going to be very good. Okay, but if you are doing it regularly, you are going to really enjoy learning this. There is a question: is there any problem? I can ask a question on your personal WhatsApp number. Unless it is a personal question, you can ask in group. The reason is because your question may be relevant to others also. So it can, if I am answering it in the group, then it can really help others also. So do not feel that okay, I am not understanding much. So there might be other people also who do not have the courage to ask that doubt. But if it is something personal, you can definitely WhatsApp me personally too. Okay, so hope you enjoyed today's session, and let us continue to learn and grow together. Be part of all initiatives. Do not just learn, also come forward and share knowledge, help people in need, and that is the only way to learn and grow together. If people who can afford can help people who cannot afford, that is the best way for everybody to grow together. See you all in next class.